for the
I'm back.
second for the second hour, and we're talking about building generative AI applications in Go.
Cool. All right. So yeah, welcome back to those who were here. How many people were here the first time? Okay. So sorry, we're just gonna do a quick recap for a couple of guys in here just to let you know what we did. But no, it's fine. It all comes together at the end. So. And we'll post all the slides, but all the code is actually here. So you already heard the large language models, I think, from Beth. So there was a couple of things that we basically showed from a code perspective, right? It was really looking at all these various frameworks that you can use in Go. There's some simple APIs. So from the Google perspective, one of the examples just shows that, of course, since we're Google and we like Go, you can call all of our models directly. We have like native APIs in Go for like everything AI related. In Google Cloud, we have native APIs, makes it easy to call. So if you're in a Google-centric world, you're good to go. But when we talked a little bit about this notion of prompting, so are you familiar with sort of prompts? So the notion of like, it's really, the models are all, maybe have subtle nuances, but to get them to do what you want, it's really important how you ask it and what information you send in, right? And this is really about the notion of designing kind of prompts. And this will be pretty important for the section that we'll do fresh right now. And then, so this becomes kind of a key input into like all the sort of standard APIs and things that you'll see in the sort of code samples. We can skip over this, but this was nice is that, so the other thing here was that with models, like while you might just do like what ChatGPT or what something does, you might just say, who is Gary Singh, send it into the model, get something back. A lot of times you need to do way more than that. So of course, like everything else, everything now has a complex stack of functions and capabilities that you need to use. So one of the things that we started to talk about is that there's a library that was written in Python called LangChain. And LangChain was fundamentally about like kind of orchestrating and building these chains and pipelines, right? So send data into the model, fetch some other data, call two models, chain models together, kind of that orchestration layer. Somebody, Travis Klein, decided that we should do this in Go also. So he created a version of I'll call it a LangChain-like thing in Go, which is beautiful. So now we have this. So Go has this ecosystem, and we got this thing called LangChain Go, phenomenal way for orchestrating models, being able to call and prompt them, create multi-stage chats, call out to like other functions, call out to vector databases, and from the LangChain perspective, and I'll show you the code. From the LangChain perspective, there's like a standard way to interface with models, right? So you can basically substitute in like a model, you can substitute in a vector database. So it's all kind of this plug-in architecture. So kind of you can write the same code, and then you can, plug and play, what model or what things you want to call in it, right? All through a sort of standard, strongly typed, interfaces. This was one of my favorite sections. The demos show calling like Gemini, ChatGPT, OpenAPI. There's a bunch of models that are available out there that you can run yourself. Lots of frameworks for running them, but there's a great framework called Ollama. Not sure if you've heard of Ollama, but we did a quick demo of Ollama. Ollama's great for running locally on your laptops, can pull down the models, and it's all written in Go. And of course, it has a Go API to use it. So that was the first section. God, I could have done this talk in like 10 minutes, I guess. So one of the demos is Gemma with Ollama. And then finally, we talked about, and we'll show this in this section. So we have, Google has native APIs. We have Ollama has the serving and the API, LangChain Go for kind of the sort of toolkit and orchestration of models and enrichment of models. And then finally, most recently added to the fray is from Firebase. They've created a new toolkit called GenKit. It's written in two languages, TypeScript and Go. We don't, for purposes here, Go is the one we care about. And what these guys cared about was don't build a separate tier for orchestration, that you should be able to essentially inline your sort of LLM flows should be able to be intermixed with your kind of business logic. So the focus here was again on a plugin architecture for calling APIs and calling like data processing. Some basic design principles there. And so there was demos for sort of each one of those. So that's, in a nutshell, was going to bring us to our last section. Oh, and then this was good because this kind of just, even though this is the way that Firebase does it, this is pretty much the way all the kind of toolkits do things, right? They have a standard way to call models. In these ones, we were specifically talking about text generation models, but even stable diffusion for image creation, you'll see the same thing, right? And essentially, all the toolkits have a standard way of implementing stuff. You can see here that it was like the AI and then the plugins for Firebase, but Ollama does this, and LangChain Go do this as well. So it's a standard interface for an LLM or a model, and you basically just kind of call out the name model, and then you're interacting with that sort of model object across all of them. LangChain defines flows, which are basically just functions. So sort of callback and sort of chains of functions. You can have multiple in a flow. In the end, in development, a flow can be exposed as a simple API that allows you to quickly test it. And then you obviously have the ability to create various types of prompts. So almost all of the toolkits will have something like one-shot chat message, which is just send one thing in. They'll have multi-turn, which is basically the model comes and says, "Hi, I'm Gemini. How can I help you?" And you say, "Hey, I'm Gary. I'm a blah blah blah. Do whatever." And you can kind of have this multi-turn, like sort of interactive conversation. So they have kind of prompts for doing that and injecting context. And in Go, these all become just strongly typed objects. But you'll find basically a set of prompt interfaces in almost all of the libraries and toolkits as well. And that was Gemini with GenKit. So the last thing, we kind of covered how to build these apps, orchestrate these apps. We showed like sending in some specific system prompts and other prompts. Now, one of the other things that came out there is this notion of like, how do I use a model but give it my own data? And one way of doing that is fine-tuning, which is basically kind of fine-tuning is a weird thing, but it's basically training a model, but without like retraining it. So if you take a model, you can then essentially strip out these outer layers, replace outer layers with data, your own data. But you essentially you're running training, and training is kind of an intensive process. And of course, if you want to add more, you have to do it again, right? So you'd have to continually fine-tune, because it's not like this sort of dynamic process, right? You're just going to continue to do it. One of the other methods that people have come up with is a notion called retrieval augmented generation, or RAG. Has everybody somewhat heard of RAG? Yeah. And fancy name for basically looking up data and sending it in. But how does RAG sort of work? This was the notion here, right? How do you get data into your LLM? Like, how do you give this thing more context and get your data in without having to specifically fine-tune or retrain your model? And this is, probably the thing most people do with a lot of these toolkits, right? Whether it be LangChain Go or whatever, is because it's the easiest thing to do is give it your own data. You're not going to be, Google, Apple, Microsoft, and whatever spending, Facebook, whatever, spending millions, millions and tens of millions of dollars, like training your models or fine-tuning a model. You're like, hey, Gemma's good enough for me, or Llama's good enough for me. I just want it to have my own sort of data that's in there. So how do you do that? So there's this notion of, called essentially RAG, right? And in simplest terms, right, RAG is about just adding more data into your sort of context. But how do you make it such that it works well? What are some of the algorithms that you can do to make this work well with sort of LLMs? And it turned out that a great way of there's a number of like algorithms out there, vector search, encodings, embeddings, which are a great way of being able to index data, kind of search on data with compares. So doing not quite the same thing as what LLMs do in their neural networks, but it's a great way of, instead of just, because you don't want to just say, like, obviously you could just pass in all text, right? If you want to say rewrite a document, you can pass in a whole blob of stuff, right? But in the sense that you have a whole bunch of information related to some query, you might have a corpus of millions and millions of records. You want to find basically something like, nearest neighbor or the ones that closely to match that. The fastest way to search for that stuff turns out to be these vector embeddings and vector embeddings for searching, right, which can create these sort of multi-relationship, sort of deep sort of networks. So it turns out that they turn out to be very useful as inputs into LLMs. So it's existing technology that's been out there for a while, and you sort of do that. So the architecture, do I have this in here? So the architecture ends up being, okay, I have to have these vector embeddings, and now there's became a newer market for what are called vector databases. There's a bunch of them out there. We have one, Pinecone, a few other ones out there, right? So essentially, you'll use a model, an embedding model, to generate text embeddings. You'll store those in a vector database, and then you'll retrieve those using it's a standard query where you just pass in the data, but it's doing a vector search on that. And then you take that data and pass that into your model as context, and then hopefully magic happens and you get something that's like more about your data than anything else. And that's RAG in a nutshell. So, in this particular case, right, you can take, we're taking we're telling it a bunch of stuff. The interesting thing is, you tell it in the prompt that you want it to use the context, right? So, interestingly enough, these models all understand fundamentally the ability to tell it to actually use something that you've given it. Right? And then in this case, it says if there's no context, don't answer the question. So in theory, this shouldn't make up an answer, or it should only be using the inputs that you give it as that data. So this is where you pass in your retrieved information, and then that's where you ask your actual question, right? So that's why the sort of prompt formats and the sort of prompt model become kind of important. Now you can do stuff like leave it, make up an answer, and have fun if you want to, but I think the more serious side is like, you want to get real answers, and you don't want, for example, the airline system chatbot that told you that you could have like a free ticket, right, or get free refunds, right? That just makes up answers. You want it to say, only do it based on this corpus of information that I'm giving you. So there's a couple parts to this. This is obviously the query side, right? You're essentially performing an operation on that. You're doing a search. It's doing an evaluation. There's a well-known set of algorithms for ranking these documents. The other side of it is how do you actually get all this information in there? And that's where you're going to use one of several embedding models, right? So you have to use a model to actually pass it into the data. It's going to generate the vector embeddings for you, and then you're going to store those in some type of vector store, and then run a query about that. So similar to just like, how you like have reference information for an application in a database, similar concept, it's just a vector database, and the way you prepare that data is by using an embeddings library or model to do it. This is just, you can read this thing in here, but it's basically just, you basically make these low dimensionals, you can put it in like that high dimensional space. So it's very similar to how Beth showed the diagram of how like the neural network models are working. This is just a different version of it with a specific set of data, indexed on more search and finding close relationships and edges that are in there, where inputs are closest together. And this just comes down to, I guess I'll just highlight that. There's a few buzzwords that are out there. Vector DBs are the buzzword. So RAG and vector DBs are the big buzzwords when it comes to augmenting your models or the things that are out there. I'm going to I'll share all the charts. I don't think anybody specifically cares about how the algorithms work, but if you do, you can read this stuff. But yeah, I mean, the easiest one is you've all probably taken some, I didn't, but maybe any of you did, the computer science tests or hacker rank whatever tests on like nearest neighbor algorithms and stuff like that. These are just extreme versions of that. And so here's the overall workflow. As I said, you can pass in documents, raw test. So you have to have something that can do the pipeline and processing, adds it to the vector database, and then on the other side you have a retrieval side, and then you have the model which takes that and then spits out an answer. And that's so again, we have a flow, right? On both sides we kind of have a flow, so that's why having these libraries that do this becomes important. And yeah, this is just kind of a different version of it that typically in my demo or the sample code that I have out there, we do both in the same one because it just makes it easier to run locally. But typically, you'd have two separate processes, right? One for doing the embeddings, and then one actually part of your application. The other important thing, I mentioned this earlier, is that just remember that while the chat interface and asking questions is the common thing that ChatGPT has made in, like, generative AI is not actually Q&A, right? So this helps to do stuff like that, right? To help, because it's giving it your specific data and context. But in the end, like, even though you might pass in exact data in these vectors, it might not spit back exactly what you stored in your vector database, right? This is generative AI. Hopefully, it's using a smaller corpus of information to do that, so it's going to find that relationship to be in there. But don't think that just because you put something in the vector database, like for example, literally like Q&A, that you would actually get back, if you ask the exact same thing, that you're going to literally get back what you put in there. But this at least helps approximate and narrow down the set of data that the model is going to kind of operate on. All right. With that, we'll just show why why people use these sort of toolkits to do it. And I think this is it. All of them support, like I said, all the toolkits support it. I chose to use GenKit here. Let's close all these things. I don't know what was going on here, so too many terminals open. All right, let's go back up to, so our function here, so this is basically our main here, hopefully. All right, so what are we doing here? So we went with the, in this case, we could have used like one of those dot prompt templates that I showed you, but we're just going to use a simple template replacement here as a string, which is nice with Google and with Go and the literal strings now. So in this case, right, we said you're an agent, so we're giving you the context. Here's the question, and then here's the context that you should actually use. Please provide the best answer that you can. So remember, prompts are important because prompts are going to be where you put the data in. The nice thing here, from an API perspective on the Go side, we can strongly type things so that we can actually say, since we know what we want to come in from the application, we want it to actually be a query and a context. That's all we care about sort of coming into this flow. We can strongly type that. And then our function is, again, our normal call our model. I decided to step up my game and pay for Gemini Pro for this demo. So we're using Gemini Pro here. We have an embedding model as well. Google has an embedding model, but there's other ones. Hugging Face has one. There's a bunch of them out there. So here we're basically just saying, here's our model, here's our embedder. Basically, the library here provides a way of sort of defining the index and the sort of retriever. So again, this is just telling you how to interact with that from a sort of standard thing. Any multiple vector databases are supported. And then here's our prompt. And in our flow, you can actually see that we're cheating. In our flow, so rather than doing what I showed you before, which is like loading up embeddings separately and then putting them in here, in this particular model, because it's just fun to play with, we're basically loading up, we're indexing and loading these into the vector database that we're using here is this thing called localvec, because it's just easier than trying to run your own vector database. You can use PG vector with Postgres, but then you have to set up your own database and all that stuff. So this is just an easy cheat. This is basically an in-memory text database That's great for testing. It can prove out that your application will work. But you could replace this with any number of like supported ones that are in there. So that's the sort of local vec. So here we're just adding in some specific documents, right? So supposedly now this thing should at least have information, knowing that it should now know specifically that Paris is the capital. It should know that USA is whatever. And remember, we've told the model that if it's not in the context, that it should say it doesn't know. And that's it. So this is kind of our flow. In this particular case, right, it just has the ability to take the prompt. As we said here, there was this prompt. That's kind of the template. And this can generate the sort of string from that, right? So that's, again, just kind of a bunch of like utility libraries, but a little bit more advanced sample than the other ones, but the same basic model. And then, yeah, document in here. Putting our request in, we're getting the retriever, we get the response back, and then here we actually pass in the, so here is basically we build a string. We have to when we get back the information from the vector database, we have to pass it in as text, so we'll just convert it to a string. And at the end, and then here we'll send in our prompt, was the original question that you added in, and as context, we're sending in the stringified version of the vector, of the information that was returned from the vector database. And that's pretty much the model that you do. And if all goes well, this should actually work. So same thing here. This will expose up an API. Oh, yeah, we've seen this error before. We now remember this. Sorry, you have to, all these require an API key, so again, all right. Oh, apparently we are still running our last demo somewhere around here. Maybe over here? Oh yeah, sorry. We got to kill our last demo. Good to know that it's kept running though. All right, so we're running up on 3400. Hopefully I was smart and I put a question up here. Oh yeah. So again, this is exposing an API here. This is I did the simple debug one. So our model here is just, we're going to pass in our question. Notice our question is, what is the capital of the UK? And then again, it's just it's always running on 3400 for local tests, and the flow is called, the flow name just becomes the path. So before I run this, what do you think the response to this should be? Close to nothing. It basically just says that the provided context does not mention the capital of the United Kingdom, so I cannot answer this question from the provided context. So in theory, if we do this, we'll do, well, I'm just going to be lazy here. We'll change this to France. Now we should actually get a, we should get an answer. So that's, so hopefully it should tell us, hey, Paris. So with that, right, we're using this sort of, obviously we can do more complicated things than this, right? This is a simple demo that compiles fast. Normally you might put an entire corpus of like, PDFs, unstructured data, all kinds of information relevant to you. For example, one good example that we're doing for like one of the, or whatever, we have this product called Cloud Assist. One of the things that we're doing there is because we can't possibly like retrain the model on all the code that's out there and all the GitHub code that's out there, and maybe you want to train it on some of your local code, like let's say you want to take, it could be Copilot, it could be our stuff, Code Assist, and you want to train it on your local code. The way that that's typically going to work right now is you're not going to fine-tune the model. What you're going to do is use vector embeddings for your actual code. You'll take the corpus of your code, you'll actually generate embeddings for that, store that in a vector database, and then you'll pass that in as a context, right? Use these as exemplars, use these as the model, and then generate code from that. And that's how like over time, you'll start to see that you can actually get the code to be more specific to maybe the style that you use, for example, as opposed to like a style that was found on the internet for training. Or again, for example, it could be like logging information or just specific information to whatever your business is. So I'd probably say that RAG is probably the most common thing that people are going to do. When you build the base flow, the chat response back and forth, and then you're going to use RAG with some type of vector database to pull back your content and data, augment that into your prompt, and then get back your stuff. And then hopefully you should have a more meaningful generative AI application that's more meaningful for whatever particular job, company, et cetera, that you work for. And again, this is pretty nice because you can test out. It's not hard. I guess that's the best thing, right? Obviously, if you were doing like PDFs and things like that, you'd use some of the Go libraries for parsing PDFs. GenKit actually provides some of those libraries. LangChain Go does too as well. String parsers, text parsers, whatever. But because you can basically retrieve data however you want, right? To pull in the raw data, just convert it into the stuff. Pass it into your embedding library, which again, we have a standard interface for embeddings. Add it to your vector database, standard retrieval interface. And so you can kind of mess around with this. So in test, I can do this, but I could then take take real data and try to do it against like a Pinecone or PG vector with a whole bunch of real information that somebody else probably knows, like not me, that we want to use. Put in the prompts, and yeah, you should have a pretty good. Hopefully, you'll have a pretty good app. It should be better than what you get, the first time around, assuming that the model wasn't trained on your data in the first place. And I think that might be. Hold on, let's see if I have any other tidbits of wisdom here. I think you can, because I think that was the end of my presentation.
Test?
Sorry about interrupting you. I was just wondering, do you have to get all of the data into a sort of common format then, like text format, to feed into the embedding, whether it's like PDFs or images or?
Yeah, it depends. It depends on the model. So like this model, so the model that we used in this particular case, I think I have to double check, but like our embeddings model, so we had one model that was specifically like a text embedding model. And if you use a text embedding model, then yeah, everything you basically have to munge it into basically a text or string, right? So you convert it from PDF to string or whatever that's in there. There are some multimodal embedding models, so that they'll actually determine the type, sort of based on what you kind of pass in, so they can accept multiple types or blobs. But typically, yeah, the embedding library is going to be specific to a MIME type or type of data. So you would have to basically convert it, right? So most of them are going to be text or image or audio, and those would be all specific formats for those models.
But with like GenKit, there might be different plugins for different data types.
Yeah, there might be. So it's with like GenKit. GenKit will have different parsers. For like right now, it has one that can convert PDF to text. It doesn't have any of the image stuff, but yeah, it could have different ones that could normalize formats to whatever the specific type of model that takes, right? So if it's an image embedding model, here would be the specific format. We would probably build a toolkit or a library that allows you to read whatever files and convert it into whatever intermediate form is needed.
Right, thanks very much.
Yeah. Any other questions?
Thank you so much for the great talk. You talk about prompt engineering.
Yeah.
Right? So what is the best approach to handling hallucinations, when you send something and you got something back, how do you confirm like it's actually perfect?
Yeah, how do you, somebody we were talking a little bit about this sort of earlier. So the world of AI testing and regression testing or GenAI testing is quite interesting, right? Because in a normal case, right, you expect when you write a test case for like your normal code, you have an input and an expected output, generally deterministic. If it's not, then you probably fix your code because your code should have been deterministic. In these cases, like you definitely your answers are not necessarily going to be deterministic, right? So the interesting thing comes down to you kind of have to use AI or other sort of models to actually sort of compare the answers, right? Think of it as in the most generic terms, it's going to be a fuzzy match. So you're going to have like I should know, for example, like if I just train this specific one, like with RAG, which it should hallucinate less, I should be able to know that my answers should, like if I say what is the capital of France, that somewhere in there I should be searching for, it should have the words capital in Paris or whatever, right? Or you can kind of do like vector match. There's different algorithms, right? So that you can match, like is it similar enough string? And images too, like pixelation and whatever. So you almost have to use another set of like similar AI or whatever tools to actually check that your answers were true. To prevent, now, if you're trying to prevent some of this stuff from happening, there's a few things that you can do. You can try in your prompt to say a number of the models out there are trained with like weird, like sort of keywords that are in there. So you can tell it to be an accurate assistant. You can tell it, if you don't know the answer, say do not know. So depending on the model or the sort of layers, you can also just adjust your basic prompts to help it avoid like blatant hallucinations where there was like nothing and it just sort of makes it up. But more specifically, if you're really going to build one out there, you're probably going to do it on a corpus of your own data, and you're going to have to do some analogous to fuzzy matches to make sure that stuff's up there. And then you're probably going to also have to like periodically just run random. I would be running like random tests on like my live running model too, right? Just to see that that it's behaving the way that I want it to, such that you don't make what's the biggest newspaper here? Or you don't make it on BBC for one of your whatever wrong answers, right? That happen because as you've seen, right, the second somebody gives a wrong answer, man, everybody's all over it, right? How that's out there. Yep.
Hi, Gary. Thank you very much for your fantastic presentation. I got two questions, if you don't mind. The first one is, have you ever experimented like AI agents locally with your models? If so, and the second one, maybe I can ask later.
I haven't done too much with AI agents yet. I've played around with modifying a few bots, right, to basically, do a couple of tasks, right? Like I was doing one where I was trying to take generate like debug dumps, and then pass them into an agent that could at least somehow kind of tell me like what was wrong with it or whatever, right? So I was kind of doing some of those sort of flows, but I haven't started to use the agent frameworks yet. A lot of them have just been recently like added to some of these toolkits as well. But they seem like a good idea. To me, it's kind of like I'd almost be doing what I'm doing here, right? Which is kind of figuring out, like messing around with prompts and things like that, like with the engines, and then kind of testing out like what output I'm expecting from whatever system I'm building sort of those sort of agents for to orchestrate for. People in Google have. And I guess there's some on GitHub too, right? That have some agents that are out there, like for checking, pull requests and formatting stuff. They started to modify some of those to be actual use AI rather than being like hard coded to chess templates. I just haven't played around too much with it yet, but that's probably my next step.
Sorry, do you think they are easy to plug and play like locally? Because I was using like Crew AI with some APIs. They work fine, but I don't have much of the expertise yet to run the models locally and just plug and play them.
I think when you start to look at I think any of the purpose of like any of these sort of toolkits for building the agents, right, whether it's LangChain Go, GenKit, or whatever, is to make it more or less plug and play for the various models. You know, like there's plugins like if you used Olama, there was one. Almost everybody has. You can choose to host it on like text generation inference, so or you know, kind of directly do it. So in general, for the text ones, yes, because there's enough common serving frameworks that every one of these toolkits has plugins for that it'll just you can just swap in and out from them. But in general, yeah, I mean I do that all the time with. From a standard, development perspective, right? I swap them in and out, and only a couple of times have I been burned, and that's only when sometimes like the spec changes or things that are in that. But it's been sort of pretty standard to be able to change things in and out and move local and push it onto the servers. Yeah.
Any other questions?
There's one in the back.
Hey, I just wanted to ask if there's a limit how big the context can be for the prompt.
Yeah, that is a fantastic question. There are. It depends on the model, how big the prompt can be. You can obviously set it also too, on the serving side, right? So you can filter it out if you don't want to have the prompt too big. But from a model perspective, yeah, and generally they tell you what their limits are based on the number of parameters. I think that we are like marketing now, like trying to go to, we were at 1 million, then 2 million, then trying to get to 1 trillion, right? For some of these, I think most of the open models that are out there are somewhere in the tens of thousands of tokens, but they might be greater than that. But yeah, once we get to So RAG becomes super interesting when you get to like the million plus, 2 million, whatever, like the super large number of tokens, because imagine it for a code, like even for a code base, right? I mean, how many characters are in a normal program, right? And now all of a sudden, because normally like the context that happens when you do code generation, right? It looks at the context and maybe it takes, if you're in like Copilot or Google Cloud Code Assist, it basically takes kind of the file that you're in and sends it. What if it could send like every file that was in your directory, right? Then that becomes an all the text, right? Then it becomes actually pretty smart, right? Like it could actually figure out that you had this implementation. So I think that becomes one of the bigger game changers for RAG, becomes when you can pass more information and context into the actual prompt itself. And there's usually a limit on the number of input tokens and the number of output tokens. But the bigger models that you'll get to are probably going to start, 100 million, trillion. So it's going to be pretty massive. Did you have a specific, just wondering, or did you have a specific use? Yeah.
Yeah, I mean, I was just wondering, I don't know if I just pass a 1,000 page PDF or, I don't know, 1 million lines of code.
Yeah.
Can it handle?
We're getting there. Some models can. But yeah, those are the interesting things to look out for, right? So every time a new model comes out, right, you always look for kind of like the accuracy, size, accuracy, number of parameters it was trained on, and then I generally look at like what is its input and output token sizes, because those are the characteristics that tend to be the I'm a better model than you side.
Thank you.
Yeah.
We have another question here, right?
Maybe related to the friend's question, and maybe naive question that as the context is growing, the size is growing, is necessity for RAG will be still there, or is it like we can provide the entire document as a context moving forward, or you see RAG is still being there?
I still think, I think RAG's still being there. I think, I think that it's always going to be, obviously the bigger the context, the better RAG can be, to a degree, right? Now I think, because you can pass, more information and more sources in, now sometimes it becomes a little bit more important how you limit, like for example, like if you're doing the vector search, you may end up having to depending on your model, you may actually have to put a limit, right, on the results, right? So maybe you only get the top, whatever, 10K, whatever, 1,000 results or whatever based on size or whatever it may be, sort of into that context. Whereas perhaps like that result actually had like it had a lot more, it had a bigger size, results that were just as accurate. So yeah, once we get to larger, the larger size, the context will be better. I think that's where RAG really starts to shine as a way to keep using existing models without having to continually fine tune them.
Okay, thank you. Is there any more questions?
Any answers?
Sorry, maybe one more for you. So from your perspective, what do you think is going to be the future of AI in sense of, how do I say, do you think like maybe agentic AI will be the future, or do you think they're going to integrate some kind of like memory where, all the prompts you do, they get like kind of memorized, and so you have something more, the thing you said about having like consistency through your questions and answers, because at the moment you can't have them deterministically. So yeah, like every time you maybe like if you do some good prompt engineering, sometimes you can like ask them to create like a language with you and get some templates always done the same way. But I don't know, like maybe in the future they are planning to do like all the same answers for the same questions, or cache them, or do something like that to make it more deterministical, if they want to do so.
Yeah, that's an interesting one. I think there is a potential notion of, especially when you start doing some of the reinforcement learning or the things that are on that, right? That perhaps like some more correct answers or things that people are doing can be, a lot of times those are used, more into like refinement of like into the like retraining and stuff like that today. It would be interesting, right, if you started to say, well, these are the more accurate results that sort of passed into this stuff. Can I more tie those into a historical context? Here are the more accurate answers that we've gotten for this in the past, and then use those kind of sort of for RAG. I think people are worried about not just having it be a free for all in automation. The problem with like things like agent systems, right, that become headless, right, is, I mean, you don't want it doing something like truly bad, right? I think that's why most of those use cases today are something that the end result is something that didn't like, I don't know, what would be a good one? Like, it didn't trigger like firing a missile, right? Or something like that, right? It's like, well, it said your pull request was bad, right? Or it reformed your thing, right? Or it generated a task order and maybe there was like some off information in there, right? With some level of like kind of human value. It seems to me there's always like some validation somewhere in these sort of systems that the output sort of goes to, as many of the agents are. I think if we go to truly like AI, like system-to-system communication that nobody has, there's no feedback in the loop, I'm not quite sure that we're there yet with GenAI. I think there's other ways to do it without GenAI that use some levels of AI, but yeah, we're probably not going to I don't know that you would, even I'm a Kubernetes person, right? So I don't know that necessarily right now, I would say, like you might say, like, here's all these errors that happened, how should you fix this? And it'll give you an answer, run this command. The next action of that is, well, just run that command for me without asking me. If I'm running like a production Kubernetes system for like BBC, I don't think I'm going to do that. I think I'm probably going to like have that be sent to be used by like an SRE or somebody like that who might apply the command. I don't know, I can't say how far we are from, from that sort of thing, but it'll be up to everybody individually, I think, based on what they see and what their, trust in the system is. I mean, just as an example, like we do stuff like today in like Kubernetes, like which isn't using AI, and we just recommend, hey, here's what you should set for your resource requests. Do you want us to apply them? And most people are like, no. recommend it, and we'll make the decision to apply it, right? So, and those are pretty accurate, right? So I don't know if I sort of answered your question, but yeah.
Okay, thank you. Any more questions? Yeah?
I just wonder, with things like GenAI and RAG and all of that, if you were to, let's say, parse, I don't know, thousands of metrics from Prometheus or something like that, I guess how does it go with working with, I guess, raw numbers and things like that, where you have tools like Grafana, which graph it nicely for us humans to kind of understand, but feeding, let's say, bulk numbers and data like that to it, I guess, is that something that, I guess, the AIs will, I mean, the models at the moment are able to do quite well, or is it somewhere where they kind of lack being able to understand, like, bulk amounts of just numbers and patterns, I guess, in that sense?
Yeah, it's a great question. I think that, so there's interesting things that you can do in there, right? Like you can, they're pretty smart in the sense of like if you give some exemplars of something, right? Or you specify like kind of what the results that come back are as. Like, let's say you're getting a bunch of metrics and they were like in whatever. You could kind of tell if they were in a table format. Like, it's almost like if you tell it, there's certain things that you can tell the sort of the AI, and if it can understand those sort of formats, it's pretty good at figuring that stuff out, right? But if you were going to give it like truly unstructured data that you couldn't somehow like describe, or that it wasn't trained on a template to understand how to come back, it would probably be harder. But like tabular data formats, graphical type stuff, like you can construct some interesting like prompts and contexts that will work with numbers. You probably would perform mathematical operations as callouts on the data, and that's sort of what those plugins or side functions are, right? If you were going to try to create like the averages or rolling averages or whatever, but for more or less like extracting and formatting, it's pretty good.
Okay, thank you. We have 8 minutes left. So if there's any more questions, we can take them. Yeah?
You got 8 minutes.
Yeah, thank you. Sorry, how do you have like maybe like a repo or maybe like a guideline of for how to deploy these kind of applications on Kubernetes, and how difficult it is? Like the kind of resources you have to like allocate for. Yeah.
So for the parts of the applications that we showed today, that part's simple because they're really just like web applications, right? Because in these cases, right, I'm always, like in this particular code, right, we're always calling out to something else that's running the model. So those parts are easy to deploy. If you wanted to, like for example, this part, so those parts are pretty easy and actually, yeah, we have a lot of people. Now, if you wanted to do this stuff, like so, I showed running like Olama on my laptop. If you actually were saying, if you chose and you said you wanted to use like Gemma or Cohere or whatever, you're like, I don't want to use Gemini. I want to use one of these freely available open models. That's what I'm going to use, which means you need to host it yourself. Right, and you could of course build the app locally, like we said here. Now, hosting the model and the serving of the model, actually, it's pretty straightforward on Kubernetes these days, right? Especially Kubernetes is very good at with GPUs and plugging into the accelerators and non-accelerators and compute side. It's actually pretty straightforward, and like running like Olama. Because the nice thing for serving, it's all straightforward because there's a number of serving frameworks that are out there. Olama. Hugging TGI, Hugging Face, Triton's inference servers, the Triton ones, they pretty much all have base Docker images for them. They can automatically discover GPUs that are on there. And there's a lot of work been going on in Kubernetes to make it easier to work with GPUs as well. So yeah, it's not a problem. Not an ad for us, but I come from the Google Kubernetes engine side. We have a ton of people running inference and training on GKE with GPUs running these models.
Okay. Any more questions? We have 5 minutes left, but if there's no more questions, we could finish.
Yep. And if
Okay. Just one more moment. Anyone else wants to ask a question?
Going.
No.
Going.
Okay. Well, thank you so much.
Thank you.
Yeah.